So we're at the final video of week 3, and we're going to keep things quite short. So what I've got for you on page 62 and 63 are just a couple of questions, more so relating to the information that you've just learned and some of the skills of like cars. And then with 63, I've got an awful table of information for you, which I'm afraid there's no real way of us refining this just yet. We need a bit more time with what is most likely to come up, but I'll talk you through that as well. So for 62. For 62, this is a common exam question that you could be asked where you're having to compare trends from one period to trends to another. Now, fortunately for you, the trends are basically all similar as you go through with a few odd exceptions. I've taught you a couple of those exceptions, but for now, we're just going to look at our melting points. So you can see here that both of these charts look at period 2, which is the carbon one, and then period 3, which is the one that we talk most about, which is just below that. You can see that the trend for going from the elements from the first 4 groups all have that similar uptrend. And then we get this big drop off around here, where there's some slight differences between these two. What the questions are going to do is going to ask you to explain what's going on at each of these stages. The first question is about the difference in melting point between lithium and then beryllium. The way to answer these questions for 3 to 4 marks is that you need to state what is that difference. Is it greater? Is it less than? Is it smaller? Is it bigger? Whatever. Tell me the difference first of all. Then you need to explain that difference. Why are they different? I like to look at how do they exist? Do lithium and beryllium exist in the same way? So that's their bonding and their structure. If they do, why is there a difference? Okay. After that, I want you to explain why does that difference affect the melting point? And that's how you get your 3 marks. So first of all, state what's actually the difference between them. Why is there that difference? So what's actually going on within these like bondings or within that structure? If it's the same, why is it different? And then finally, relate that back to the melting point. How does that impact the melting point? You can do the same for C. So for C, same question to yourself. Why does C have the highest melting point? Okay, how does C normally or typically exist? How can it exist? Why is it so high? Okay, why does that, the way that it exists, make that so different? Then finally, link that to its melting point. So there you're kind of describing the structure of it, the type of bonding that's within it, and why that affects its melting point. The last question, again, not too dissimilar. Period 2, nitrogen and oxygen. I'll highlight these so you can see where I'm looking. So period 2, nitrogen and oxygen. We're looking around here. So these ones on here. And then what we're going to do is we're going to compare them to phosphorus and sulfur. Let me make that a bit clearer for you. There we go. So we're comparing these two. So these two, how do they exist? Why is that? Why are they different? So what type of bonding or structure did these guys have? And then can you explain the differences of why these ones are so much lower than the ones in the group below? Like, don't get me wrong, they're both low, but why is it that nitrogen and oxygen in group 2, period 2, are much lower than phosphorus and sulfur in period 3? And again, the question comes back to how do these things exist naturally? If you can answer that question, then you should be able to get those 3 marks. Right, I'm going to leave you to have a go at this, and then I'm going to bore you with page 63. Right, page 63. I'll be honest, this table was full, and then I realized that it just looked like a big blur of text. And I think even looking at it now, you're probably thinking, oh my God, do I need to remember everything in here? Um, yes and no. So some of the things that like physical and chemical properties you can understand. So like magnesium is metallic. It's got strong electrostatic attraction between positive central metal ion and a sea of delocalized electrons. That gives it a very high melting point. So some of those things you can deduce from the information that you know. The uses, so the uses column, so you can see where my eyes are looking. The uses column's around here, and we do actually need to know the uses of common oxides for period 3 and common chlorides for period 3. And as you can imagine, something could be used for a bazillion different things. Like, for example, sodium chloride, we can use it as table salt to make your food taste nice, or we can use it to de-ice roads and soften water. So it's like, not quite sure how many bazillion of the uses they want you to know, but I do think they want you to know the most common and appropriate ones. I think magnesium oxide as a refractory material, very, very common. Also as an antacid. If you don't know what those terms mean, now is your chance to look them up, especially refractory, because I'm pretty sure none of you know what that means. Then you got phosphorus, which is used as a drying agent. It's also hygroscopic. Have a look what that means. And then you've got silicon tetrachloride. Typically, if you ever hear anything about silicon, think computers, electronics. That's essentially what all of them are made out of. Um, Nobody knows how they work apart from the people who make them. And it is absolutely insane when you start to look into how they make silicon, make computers. It still completely baffles me to this day. It's not my field. Um, but silicon and computers just go hand in hand. So typically, when you're looking for silicon uses, you're going to mention something about computers and electronics. Um, this will come with repetitive practice of you hearing these compounds and their uses over and over again. So we will try and link them as we go throughout the course, but for the most part, it's only going to come up as maybe a one marker. So for those of you that are wanting that one mark and you've done a little bit of work and looking into these things, you find it maybe a bit interesting, there's the mark for you. So you get a nice free mark when you enter that paper. What I'd like to do is just have a look at these multiple choice questions, use the table, see if you can apply the information, and that's it. All right, I'll see you guys next week.